this point, modulus has been quite friendly. We solved equations like modulus of x is equal to 4, which is the distance of x from 0 to be 4, and modulus of x minus 3 is equal to 5, which is the value, the variable x, which is at a distance of 5 from 3, that is going to be 8 and negative 2. So we know it. But Cambridge now changes one symbol, and this equality sign becomes now inequality. So modulus of x is less than 4. Now assume all the values that are at a distance of less than 4 from 0. So it is going to be, so this is 4, this is 4, this is negative 4. So we are talking about all these values. So 1 or 1.5 or 3.99 or 2.8, all these values are at a distance of less than 4 from 0, and negative 0.8, negative 3.99, negative 3, all these values are also at a distance of less than 4 from 0. So we will say that x lies between 4 and negative 4. Okay, so whenever it's less than, we are talking about the inside thing, right? So if modulus of x is less than a, then x lies between a and negative a. So that's a general rule. Okay. Now let's do a second case. What if it was modulus of x is greater than 4? Then we are talking about all the values that are beyond a distance of 4 from 0. So this is 4, this is 0, this is negative 4. So we are saying all the values that are beyond a distance of 0 from 4. So it is going to be 4.1, 5.1, 1000, and beyond that. So anything that is greater than 4, and at this point, negative 4.111, negative 4.001, negative 5, negative 8000, and whatever. Or x is less than negative 4. So the general rule is that for modulus of x greater than a is going to be x is greater than a, or x is less than minus a. Okay, so the rule is that greater than is outside and less than is inside. So students memorize this, which is not really the right way of understanding the concepts. Students should be able to visualize it instead of just memorizing it. So if you even if you forget the formula in the exam, the number line will still save you. Now, a hero question or a P3 type question in exam is not going to be like the above. However, it is going to be like 2x minus 1 is greater than 3 times modulus of x plus 2, right? Now, this is telling us, now the best approach in this one is to solve it algebraically or graphically. But if you go in plotting it graphically, which I just explained to you, then you're going to plot it, and you're going to find the intersection. So it is going to give you two curves, two v type functions like this, and or like this, and you are going to find this solution. Okay, wait a second. So we will have something like this, let's say. So you're going to find this solution and this solution, and I told you how to find. So this is going to be y equals to 2x minus 1, and this line is going to be y equals to 3x plus 6. This line is going to be y equals to 1 minus 2x. I multiplied this entire thing by negative, and this line is going to be y equals to negative 3x negative 6. Okay, so you are going to solve the relevant ones simultaneously in order to find these. And when it says that this one is greater than this one, then that means that we are talking about the solutions which are between these. So I may have plotted the line, I may have just plotted it incorrectly as well. So, and we can do a little demonstration on, okay, so let's do a little demonstration on Desmos in order to give you a better example and to plot it perfectly, because right now let's not waste this lecture's time and doing a proper plotting. Let's do it quickly here. So 2x minus 1 equals to 2x modulus. So modulus function is usually okay, I don't see a modulus here. So what I'm going to do is, Okay, 2x minus 1, y equals to 1 minus 2x, right? And y equals to 3x plus 6, and y equals to minus 3x minus 6 minus 3, sorry, minus 3x minus 6. So now we are talking about everything that this 2x plus 1, this white, this red and blue line being above this red and blue line, this red and this blue, this is red, this is blue, reflecting at this particular point, is above this line, the green and purple line. Okay, so it is between this point, right, and this point, minus 7 and minus 1, and we are going to see algebraically how it happens. Okay, now let's come back. Now the best approach will be to square both the sides in this one. Okay, so because this is 2x minus 1, modulus is greater than 3 times of modulus x plus 2, so we square both the sides because both sides are modulus expressions, both sides are non-negative, so squaring will not create any extraneous solutions. And an extraneous solution is a fake solution that appears during the process of solving an equation but which is not actually valid, the solution I'm talking about. So let's square both the sides. So this gives me 9x squared minus 4x squared is 5x squared, and then plus 4x 12, so this becomes 4x 12x, 12x minus 4x is 8x. Oh, sorry, so this is 36, so this is 5x squared, and then 36 minus plus 36, and then plus 4 is plus 40x, and then 9 times 4 is 36, minus 1 is plus 35, is less than 0. Divide everything by 5, which is a positive quantity, so this inequality sign doesn't change. So this is x squared plus 8x plus 7 is less than 0. So this becomes x plus 7, x plus 1 is less than 0. So this is a minimum type curve. You can see that this is a minimum type curve because a is less than 0 and the roots are going to be between -1 and -7, and we are talking about, do not confuse this quadratic which was obtained to get a solution with the lines that we just saw in Desmos. So we are now considering these values which are less than 0, right? So x is going to be between -1 and -7, which we exactly saw in our Desmos as well, that this value, okay, so this disappeared, never mind. So we saw that the line that was between, that was above, was here at x is equal to -7, and this was x is equal to -1. Okay, now, so this was a P3 style question, and method 3 is also always going to verify, right? So x is only valid between -1 and -7. You take any value beyond that, let's say you take x is equal to 0 or x is equal to -10, this is not going to hold, and we can check right now. Take x is equal to 0. When x is 0, this is modulus of -1 is greater than 3 times of modulus of 2, which is invalid because 1 is not greater than 6, invalid. Now let's take -10. -10 is going to give me -21 modulus is greater than 3 times -12, which is 36. So 21 is greater than 36, not valid, right? Now let's take a value between -7 and -1, that is, let's say -5. Okay, so -5 is going to give me -11 modulus is greater than 3 times -5 plus 2 is what? -5 plus 2 is -3, -3 modulus is 3, 3 times 3 is 9. So this, the left hand side is going to be 11, so 11 definitely is going to be greater than 9. So this is now verified. Always do that in modulus questions. Now the graph made sense because these were two V shapes. The solutions occur where the first graph, y equals to modulus of 2x minus 1, right? It lied above the second, which was y equals to 3 times modulus of x plus 2, which we just saw. So the graphs intersected at x is equal to -7, which I just showed you at -7, and x is equal to -1. Between these points, the first graph sat higher. Therefore, x lies between -7 and -1. Now notice something. Distance gave us intuition. right? So distance gave us intuition. I will write all these points down. Algebra gave us the answer, and verification confirmed it, right? I hope you can relate to all these three. That's how P3 students should solve modulus inequalities, not by memorizing 10 different cases, by looking at all those types of questions that have occurred in the topical past papers on Papa Cambridge, but by understanding what modulus really means. So our final answer here is going to be that x lies between -7 and -1. Before we finish, let me show you the mistakes that cost students mark every single year. If you avoid these 4 mistakes, your modulus questions become much safer. Now, whenever students are given modulus of x is less than 3, they rush towards squaring both the sides. Now, this works here, but if you don't understand why it works, you'll get destroyed in harder inequalities. Okay, always understand the distance first. So if modulus of x is less than 3, write down that x is between positive 3 and -3. Even this case is true between this is less than 5. So you will write down 2x minus 1 is less than 5 and is greater than -5, and then you will add 1 to all the sides. So this is going to become 2x is less than 6 and -4, and then you divide all 3 sides by 2, so you get less than 3 and greater than -2, right? So make sure that you are doing distance first and algebra second. Now, trap number 2, or the second mistake that students make is, if you're given x minus 2 is equal to 5, so students are just going to find out one solution, x is equal to 7, and they're going to miss x is equal to 3, which x is equal to -3, which is the worst thing that you can do in an exam, losing like very, very simple marks, right? So distance, always remember that distance from an origin has 2 directions, one to the right on the number line and one to the left. But if you are on a Cartesian plane, then it's an entire circle that you are going to do in complex numbers that you did in circles in P1 as well, right? So always ask yourself, did I find out both sides of the distance? Now, trap number 3, or the third place where students find it difficult, or they do the question incorrectly. So whenever they're given modulus of x is greater than 3, they will write down that x lies between 3 and -3. Wrong. I told you, just memorize it, because I've explained it earlier in the video as well. So I will now ask you to just memorize it. This first case is x lies between a and -a inside, and the second case is x is greater than 9 or x is less than -9, because the two equations cannot occur simultaneously. So a quantity that is greater than 9, let's say 10, so that cannot be less than -9 as well, right? It cannot coexist. But in the first case, if I say that x lies between, okay, so this is a and not 9, I was considering, okay, so if let's say this is 9. Okay, now if this is between 9 and -9, let's say if I take 7, so 7 is both less than 9 and greater than -9. So we don't need to write or here. Okay, so remember the visual. Less than means inside, greater than means outside. Okay, now trap number 4, or the fourth mistake that students usually find, is probably the biggest one, that students try to do everything algebraically, then they get confused. So if I have modulus of x minus 4, let's say, is less than 2, let me start a new page, then instead of guessing, draw 2, 4, 6. Why? Because 4 is right in the middle, 2 is the distance from here, and 2 is the distance from here. So we will have a 2 here and we will have a 6 here. So 2, 4, 6. Okay. Distance from 4 is less than 2. So we are talking about these values. These values, and distance of 4 is less than 2 on the left hand side as well. So we will say that x lies between 6 and 2. And you can do it algebraically as well, through distance as well, that I told you that x minus 4 is less than 2 and -2. And then you add 4 to all the sides. So this is x is between 6 and 2. Okay, so 10 seconds, no memorization and no panic. And my final advice to you guys will be that whenever you see modulus in P3, ask yourself one question: what distance is Cambridge talking about? If you answer that correctly, if you're able to answer that correctly, the algebra becomes easy. If you forget that, modulus becomes one of the hardest topics in the chapter. Now, let's finish by revisiting the one idea that this entire lecture was built around. Modulus, I will write it down with red so you don't forget. Modulus is equal to distance. Not brackets, not cases, no plus minus, no graphs one above the other, but no memorization exercises, just distance. Today we started with something very simple, that modulus of 5 is modulus of x is plus and minus x. We started with definition, and from that single idea we were able to solve the equations modulus of x minus 3 is equal to 5. Then we solved harder equations like modulus of 2x minus 1 is equal to 7. Then we tackled inequalities, modulus of x less than 3 and greater than 3, and finally we solved a genuine P3 style quest problem, which was modulus of 2x minus 1 is greater than 3 times modulus of x plus 2, and we tried to do that through graph, through completing the square, through squaring both the sides, and then verification as well, all using the same idea, distance. So modulus is equal to distance. Equations will usually have two solutions. Okay, less than means inside, greater than means outside, and always draw the number line, okay, whenever you are dealing with one variable. Students, and if you think that my writing is not really clear or I'm not speaking very clearly, please always turn the subtitles on, and or if I am speaking too slowly, you can increase the speeds as well. Okay, now students who struggle with modulus see lots of different formulas. Students who score highly see one idea repeated over and over again, and I'll repeat again, distance. The moment you start thinking visually, modulus becomes much easier. Now, if you have looked ahead in the P3 syllabus, you might be wondering, what does modulus have to do with polynomial division or factor theorem or partial fractions? The answer is that we are building an algebra toolkit. Modulus teaches us how to think. Polynomial division teaches us how to break complicated expressions apart. For example, if it's two quadratic factors, two quadratic polynomials multiplying for a quartic, or if there's a linear expression multiplying with a quadratic to give us a cubic. So factor theorem helps us find roots, right? Partial fractions helps us simplify rational functions, the fractions, and binomial expansion helps us manipulate expressions efficiently, and we will see the limits of those. Each topic builds on the algebraic fluency needed for the next, and which we are going to use in our differential equations, in complex numbers, and in calculus as well, and differentiation and integration as well. So tomorrow or day after, we are going to cover polynomial division, and most likely tomorrow only we are going to cover polynomial division, and I'll show you why it is one of the most underrated topics in Pure 3. Most students learn a method, very few understand why they are dividing in the first place. Once you understand that, factor theorem becomes significantly easier. And one more thing, even if you're not enrolled in our classes, follow this series. Over the next few weeks, I'll be breaking down the key ideas of P3 algebra publicly, and then followed by all the rest of the topics as well of P1, P3, S1 and S2. So you might want to explore the channel. So whether you are studying with us or not, doesn't matter, you can still learn alongside us. If you want to follow us on Instagram, go on Easy Talim, TALEEM. If you have any query, you can reach out to me at +92 329 485. If this lecture helped you, subscribe to the channel, share it with a friend preparing for 9709 Pure Mathematics, and let me know in the comment which topic you struggle with most in P3. I'm Sir Irfan from Easy Talim. I'll see you tomorrow for polynomial division.